I'm going to get us started now. I think looks like folks are still joining a little bit, but we'll get going. I'm Tim Erlin. I'm the VP of Product at Wallarm, and I want to thank you all for joining us today for this webinar. We're going to talk about the results from our 2025 API Threat Stats Report, and really the theme there is this convergence of AI and API security. I am joined today by Stepan Ilian, who's the co-founder of Wallarm. So welcome, Stepan. I'm looking forward to this. I think it's going to be a fun conversation.
It will be a fun conversation. I must say you have an amazing DJing skills, like turn on music, turn off music, speaking in between. It was very nicely done.
Good. It takes practice, hours and
Yeah,
hours of practice, right?
totally.
All right, let's dive in. So, just to give you a sense of what we're going to talk about, the agenda, in case you're wondering, we'll spend a couple of slides just explaining what threat stats is and why we do this work. We'll provide an update to our API Threat Stats Top 10, and then we'll dive into the key findings from the report and chat about those, and wrap up with questions at the end. So from a housekeeping standpoint, if you have questions, we are broadcasting on LinkedIn and Zoom. So if you're on Zoom, you can put questions into the Q&A there. If you're on LinkedIn, you can put them into the LinkedIn chat. We'll try and pick those up a little bit as we go or at the end, depending on what we have time for or how things work out in the webinar. So with that, let's start by just talking a little bit about why we're here and what this threat stats report is. So Wallarm does a quarterly threat stats report and then an annual summary. And what we're really focused on are API risks. So this is intended to provide the industry with an explanation of the API vulnerabilities, API risks, API threats that are out there. And we aim to do this in a sort of research-oriented way. So we want to look at all of the vulnerabilities, all of the attacks, all of the exploits, and correlate those together. The data that we're using looks something like this. So we have kind of a data funnel. We obviously look at the data collected by our own platform. So that's lots and lots of API attacks that we can mine. We look at all of the publicly available data that's reported around risks and vulnerabilities. So you could say security bulletins, things like that. We look at some bug bounty reporting data, and we look at all of the API exploits that are published or that we can find in the market as well. And we combine all of that together to produce this analysis. The methodology looks roughly like this. We collect all the data, we then filter and normalize it so that we can actually perform the analysis, and then we classify and analyze that data using both AI and manual methods to do so. And the reason we do that, there are kind of three reasons. The first is that doing this kind of an analysis on a regular basis gives us that real-time analysis of API attacks and threats. It allows us to constantly and continuously update the detection in our own products, and also to improve and extend the risk models that we use in the product as well. We also feel like the results are interesting and valuable for the industry as a whole, so we like to share them, outside of Wallarm with all of you folks on a regular basis as well. And that's why we're here to talk about those results from the report.
I think this is
So
the eighth report now. So we've been doing this for 2 years now. I think this is the eighth one. So we not
yeah,
only see it in the at the moment, but also track what's happening year over year, months over months, quarter over quarter. But we'll talk about that.
yeah, and of course it has sort of improved and changed over time from the first one to the most current. So continuous improvement in what we're doing is important as well. So let's dive into the API Threat Stats Top 10. Stepan, maybe you can talk a little bit about what this top 10 represents and how it's different from some of the things that people might recognize, like the OWASP API Top 10.
Yeah, totally, totally. I mean, I think this is the number one question. When we talk about the API threat stats, everybody's asking, well, what about OWASP API security? And I say, yeah, it's amazing that we have OWASP API security, but it's always good to have other sources so you can compare and understand what the real dynamic is. Our problem with the OWASP API security, which we, by the way, contribute to and we have a lot of respect to, but it's a kind of aesthetic. It's updated once a year, and it's not always clear what is behind those rankings, what are the data sources, and obviously there's a lot of people who contribute, including ourselves, but we just wanted to see for ourselves what are the real threats today. Let's say it's January 2025. what are the real threats? Like, what are the ranking? What do we see across our customers, and what do we see in the CVEs? And they just give us a clear picture of what we need to react to, like how to be ahead of the curve. And that's why we do this research all the time. And if you look at the old WASP API security, I don't think injection is still, it's not there, right? Like it's still
No,
not there. It is in the old WASP API, like it's in the OWASP top 10, but it's not in the OWASP API security. But for us, it's a kind of a strange. I mean, like if we look into the CVEs, we look into the attacks against the APIs. Now with this LLMs and prompt injections, like injections are there, and yes, they're already included in the OWASP top 10, but like why wouldn't be they included in the WASP API security? It's still a big secret for us. So
well,
just yeah, go ahead.
yeah, and I think you're pointing out, so in the API OWASP API top 10, injections used to be a separate category, and then it got combined with another category, and it's honestly, I think it's at the bottom of that. That category is at the bottom of the OWASP API top 10. But in our research, injections as an attack type remains at the top. You can see that it was the number one in 2024. It stayed number one, kind of bounced between one and two. But if you're not looking at injections as an API threat type specifically, from the data we have, you're missing a significant threat, and that's a big difference.
Yeah, you're doing yourself a disservice because you can think, oh, we're talking about the APIs. I mean, by definition, like the data that is coming as an input to the app or API, like it's better sanitized because it's an API. There's a parameters. Like a lot of people would argue, hey, is injection still the case for the APIs? Hell yeah, we see all the time. So like if you are not looking into it, and that's why this absence of injection in the API or WASP API security is such a big deal in our case, is because like people just don't think about one of the most critical issue that is out there. And it was the case in 2024. It will be the case in 2025. And yeah, just like we just need to keep in mind, even though it's been there forever, it doesn't mean that it shouldn't be in the new report or new ranking. So that's the point.
Yeah, yeah. In fact, if we materially improve the protections across the industry against API injections, it should then move down in the top 10, and we're not seeing that in the data. There are two other changes.
So last thing on this, and because this topic of this webinar is like convergence of AI and API security. I mean, like with the AI security, you have the whole new spectrum of injections.
Yeah, absolutely.
Prompt injections. And all the different stuff you can do, the jailbreaking of the model. So like it's actually even more actual as never before. So like we'll talk about this a bit later.
Yeah, absolutely. So there are two changes here in the top 10 that I think are worth pointing out. First is the shift in the broken access control category. It moved from spot number 5 to spot number 2. But it's interesting to note that it had a significant jump in Q1 from 5 to number 1, and then kind of bounced around a little bit to end up at number 2. And we'll see that shows up in some of the top breaches that we talked about. So that broken access control category has become more important. And then the other change is that we added a new category for memory corruption and overflows. And the reason we added this category is because in the analysis of vulnerabilities, we saw a significant increase in the number of API vulnerabilities that we mapped to CWE, common weakness enumeration categories that were related to memory corruption and overflow. So it's not an arbitrary addition. It's based on seeing an increase in the number of risks that are mapped to those CWEs, and that's what added that category. We believe that that's driven in part by the increased adoption of AI APIs and the way that those are implemented, in some cases as binary APIs, but with more direct access to memory, essentially, because of their need for performance. And so that category, we'll see how it continues to perform through 2025, but that's a new category that we added there.
We'll see more and more of it. Maybe this is not the number one thing average company needs to think about, obviously, but since we're rushing into optimizing the cost for the AI, there will be much more low-level software with a direct access to the memory. So like I just expect to see more and more of it.
Mm-hmm. Yep, absolutely. Okay, let's move on to talk about some of the key findings. I think that the first place we're going to start is with those top API breaches. So in the report itself, there are more than we're going to show in the presentation and the webinar itself. We're just going to cover the top 3, talk about those. It'll give you a flavor for what's included in the report itself. So at the top of the list, we have this breach that occurred with Dell. And I thought this was a particularly interesting breach because there were multiple steps involved. And they're not all technical. So the first step involved in this incident was that there was a partner portal run by Dell that you could sign up for as a partner with basically no validation process. So you could create fake accounts, which is a kind of vulnerability, but it's really a process issue. With that fake account in place, you could then actually access data based on Dell service tags, and the metadata included some personally identifiable data, but you could essentially look up service tags. The attacker in this case created a tool to generate service tags that he could then look up. And so there was a broken access control issue there. And then lastly, there was a rate limiting issue. So the attacker over a period of 3 weeks was running API requests at a rate of something like 5,000 requests per minute, with no consequence. No one seemed to notice. So zero rate limiting. So Stepan, I mean, I think we're starting to see a trend here where these incidents are becoming more multi-step in their nature as APIs become more ubiquitous. Is that something you're seeing as well? Do you concur?
Yeah, I think it was always a case. I mean, like if you look into the, if you read a report of some kind of breach, it's always a multi-step process from the attackers, and obviously they try to mix and match different kind of techniques, exploits. They change in their approach along the way. So it's not new in a way, but like I think with the API security, like we just see more combinations of different things related to the API specifically, and maybe like 49 million user affected is not a big number. It's not the largest for sure, but we just like have it in the top just because like we want to highlight that there is a combination of different issues and threats that the companies are facing. And like one thing that will not necessarily lead to the data breach, but like when you don't have the proper process in place or proper authentication, then you don't have the rate limiting or any API abuse prevention techniques. In a combination, this can result in this pretty material breach after all, and that would be very unfortunate.
Yeah, and we'll actually cover in a different slide a bit about the speed at which data can be extracted from APIs, because that's also a factor in the increase in breaches overall. Is that compared to other methods, scraping data from APIs can be much faster and allows attackers to compromise more data in less time.
What's interesting, by the way, is that typically when we talk about the web vulnerabilities, like the like old-fashioned, I'm saying they're old-fashioned, but they're happening still pretty much every day. Breaches when the attackers get an access to the database, they usually just like dump the whole thing, username, passwords, even in encrypted form. With the API specific data breaches, like with the attacker wouldn't necessarily get the passwords when they are encrypted form, but they still would be able to download like a lot of sensitive data. Even in this case with the Dell, like it's 49 million of people actually like their home address and like phone number, like it's pretty sensitive data. Yeah, and it's not necessarily like username and password, but I think we pose this like era when the password of the user is the most important asset, but like a lot of other valuable data is actually out there. And unfortunately, this is accessible over the API, and the attackers are taking efforts to get this through the different kind of APIs. And if you don't have some basic, stuff like rate limiting, you will unfortunately experience this unfortunate events.
Yeah, that's true. So the second breach that we wanted to pull out was with Twilio, and in fact, it was in their two-factor authentication application called Authy, and here the vulnerability was basically an unprotected or unauthenticated endpoint that let you look up phone numbers, and so it gave the attacker the ability to take a big list of phone numbers and validate which of them were actually in use by that two-factor authentication app. And you can imagine that if you're looking at compromising two-factor authentication, understanding or creating malicious messages for two-factor authentication, understanding which phone numbers are actually using that app would be incredibly valuable. So essentially an unauthenticated API which falls under that category of broken access control, and facilitates then additional attacks in the future.
I just
So
want to
we
say, yeah, I just want to say that like we're making this top thing, which I don't want us to name shame companies or whatever, because I have a lot of respect to a lot of companies that are on the list, especially like Twilio is an amazing API company. They have a phenomenal security team, whom we know like at least a few people there. So just like an indication that this kind of stuff can happen to everyone. And we just use these examples of the data breaches because they are real and it's easy to convey the importance to know about different kind of threats and security misconfigurations, what the consequence can be. With the Twilio, I think everything starts with this unauthenticated API endpoint. And yeah, I mean, like if you operate at the level of Twilio and other tech companies, there is no single person in the company who actually will know like how many APIs you have. The governance is a nightmare. And it's just like, and I know that this is our playbook to talk about the importance of the discovery and governance, this kind of stuff. But like, this is the reality. It's only one API that's needed for the attackers to find. There's no authentication to start this attack chain. Like what do we see? Just like it's not possible without the external help right now. You really need to have some solutions in place. It doesn't necessarily a commercial product, but it can be just open source tools. But having this proactive discovery, proactive ways to find the APIs, find like where the authentication is missing is just like crucially important.
Yeah, absolutely, and you're absolutely right. The goal is to educate and learn about from these incidents so that we can implement controls and improve the situation overall. So the last one is another interesting example, the Internet Archive. So moving away from some commercial organizations towards nonprofits. And in this case, this is another multi-step incident where that started with a leaked API key via GitLab that provided access to source code, which in turn contained additional API tokens that provided access to Zendesk support system. And so, you might be wondering, as I was when we saw this incident, what kind of sensitive data the Internet Archive might have. Well, they actually have registered users, and if you want something changed or taken down, a page pulled, you have to demonstrate that you own it, which involves communicating some personal data. And so there were a number of users, 31 million, that were impacted by this incident. Categorized authentication flaws by, if we were using the OWASP categories, for the Wallarm top 10, we would put that in API leaks as a category. We created a separate category for that as well. So thought that was an interesting one worth sharing. I don't know, Stepan, if there's anything you wanted to add to that.
API leaks are still and will be a major issue. And a lot of companies don't really realize like how many different API secrets are leaked accidentally for themselves. So it's always a good idea just to have a project maybe once a quarter, just thinking how to make it practical for people attending, where you basically inspect all the possible places where the API leaks can be leaked. And I would start with the GitHub, GitLab, Postman collections and other things, because unfortunately we're all people, developers are people, like with all the pressure to ship faster as we put on our developers and engineers, like it's always easy to do this kind of mistakes. So like I would do this like a regular exercise, maybe a day in the quarter, just to proactively look for the API leaks.
Yeah, great. So let's move on to the next key finding, which is really about the AI threat landscape. And I'll admit that there's only one letter difference between API and AI. So we have to try and be very specific when we're talking about AI versus API, especially when we're talking about the convergence of the two, which is what we really think the results sort of point towards. So here we're talking about AI vulnerabilities, not specifically API vulnerabilities. And what we saw here was a dramatic increase in the number of CVEs that are AI related. From 39 in 2023 up to 439 in 2024. So that's more than 1,000% increase. And Stepan, maybe it's obvious, but why do we think we saw this giant increase in the number of vulnerabilities?
I mean, like, why are you using ChatGPT now every day? I mean, like this, I think that's
Exactly.
all related. It's just like why we all installed DeepSeek on our phone this week, and maybe even run it locally in our laptops. I mean, like this is our life now, and I think that's a direct relation there.
Yeah, I absolutely agree. It's similar. It's a pattern we've seen in the past. When there's a dramatic adoption of a particular technology, you'll see the threat landscape expand for that technology as well.
Yeah, but also next slide can give a little bit more details about like how we see this.
Yeah, exactly. So, yeah, what do we mean by AI vulnerabilities? How are they related?
Yeah, so like we basically group them into the two buckets. Like one is directly API related, and the others that are not necessarily API related. So like in the first bucket, everything that is um, something like weak API authentication or inadequate rate limiting or broken access controls. Like if, when we see those things, we say, oh, that's actually API security. And there is a lot of posts out there. Like we talked to a lot of people who are actually think, hey, like API security and AI security, they overlap a lot. Those are not necessarily the same thing. Don't get us wrong. It is not. But there is a huge overlap there. And along the last few months, like what do we see? The main issue for the AI companies, AI-based products, is not necessarily related to the problems of the AI itself, but it's more related to the product security issues, and that makes it even more interesting to us to dig into and to see like what are the new trends out there from the API security perspective. But what do we see right now is that we have these two types of vulnerabilities. The number is growing really, really fast, and it's just good for us to have this taxonomy so that we can react better from our own research and like product development. But I think it's good to share this with the community too, and it may be a good food for thought. What do you think about this?
Yeah, so I think there's a statistic, a metric that we skipped between these two slides. So the number of AI related vulnerabilities, and then yeah, I think it's 98.6% of those AI vulnerabilities are related to APIs. And so then it breaks down into how they're related. So the key message there, or the key conclusion, is that not just that there's a rise in AI vulnerabilities, but that the vast majority of them are related to APIs either directly or indirectly. And that's how we end up at this conclusion that there's a convergence between AI and API security because they're so tightly connected in the data that we've analyzed.
Totally.
So when we talk about AI vulnerabilities, we are talking at least in part about vulnerabilities in products, right? Commercial products that are available. If you've sat through other, webinars or presentations about vulnerabilities, they're often in products that are sort of household names, right? That you might know. When we start looking at the AI space, you're starting to see new product names or companies appear. So these may not be names that you're familiar with, but these are the kinds of tools that are being built in and integrated into generative AI deployments in large enterprises across the board. And in the report, there's a longer list. We just pulled out the top three, along with the number of CVEs that were reported against them. So Paddle, anything LLM, LangChain experimental. These are all tools related to deploying AI, operating AI in your environment, and they're names that you should look out for because, as we talked about, the increase in the threat landscape follows the increase in adoption. So you're going to find that the tools that have a large number of CVEs means that attackers are paying attention to them, researchers are paying attention to them. They're also high on the list in terms of um, you know, AI tools and libraries that are being implemented
But
in
also, but
enterprises.
also like these new tools very quickly became a part of the tech stack, kind of like
Yes.
a core tech stack. As a result of it, they became the extension of the attack surface. And like oftentimes when we talk about the AI security, we think about this problems about the LLM security and jailbreaks, when in reality, a lot of the breaches that might happen today actually related to the API or app vulnerabilities in the tech stack. I'm reading this book. It's an amazing book. I recommend it a lot to everyone right now. It's called LLM Engineer's Handbook. It's a lot about like how to put this processes in place, like building AI applications with LLMs, LangChain, and stuff. And it's inevitable that you will be adding more tools, and everybody's learning right now. Like every single company out there, not necessarily even tech company, but like the regular companies, they are experimenting right now, trying to build this AI workflows, AI apps, AI agents, making these agents talk to each other, and everybody's learning and doing mistakes. So like there's a lot of opportunity for the attackers to get leverage out of the situation. So just keep in mind, this is a new attack surface for you. Things are moving really fast, and there is unfortunately a lot of issues in the way how these products are developed, but also like a lot of issues how these products are deployed, a lot of issues of how they integrated to each other. So like there's a whole new world. We're talking a lot with the different product security teams, and you can see how everybody is overwhelmed because everybody understands, hey, this is our big problem, but there's no kind of like universally accepted approach how to deal with this. While everybody's learning how to start using it, like we're all trying to learn how to protect this and make and build those AI based applications in a more secure way.
So it's interesting because you bring up that landscape and how it's different. The tech stack, if you will. I think this slide is maybe a step up from that, right? We're not talking about the tech stack specifically, but kind of a taxonomy of generative AI products that are out there. And as we're sort of building this out, I find this really helpful to understand, what's out there in the market. When we talk about AI security, what is it that we actually have to consider securing? And there are multiple categories here. So, Stefan, do you want to talk a little bit about these? We can take turns if you want.
I can start with a few of them, but you can add on top of it. But like obviously, when we talk about the AI security, there's a whole big chunk of what do we call like security of the native LLMs. Like when you need to train those LLMs and deploy these LLMs in a secure way. I mean, this is the big problem, but quite frankly, this is a big problem for companies that are producing these foundational models like Meta and X and the OpenAI, obviously. Probably less a problem for everybody else. I mean, it is a problem in a way that like we all rely on this in a way, OpenAI and other APIs, but like it's less about like doing something for ourselves. We just need to keep this in mind. And then you have this different category where maybe you can describe like what is the difference between AI proxies and the AI inspired APIs, which we discussed.
Yeah. So I think this is a difference that is maybe subtle but interesting and worthwhile. So if you talk about an AI proxy, this is where there are transparent API calls to some LLM. So you as a user understand that you're interacting with an LLM on the back end, and it's clear to you. So we gave an example here. Zapier has an AI Gen AI based tool that generates code. They've got some clever marketing around putting the code back in no code, which I liked. But it's clear that it's an API to an LLM. The AI inspired APIs are less clear. So that's where there isn't direct communication between the user and the LLM or the AI, but that the product or platform or whatever it is providing AI based features behind the scenes. So those API calls are internal to the application, but they're still occurring. There's still an LLM back there that is being interacted with via API. So there's some difference there. And then I think the one that's coming to the top of the list you're about to talk about.
I think like the most, interesting from the security practitioner's perspective is this agentic AI security, because like this is the future. Like we all started to use ChatGPT. I think it's the workflow for pretty much every one of us right now, like on the daily basis. But we see this dramatic move into offloading our work to the agents. And as an extension of it, let me talk a little bit about the agents. At the end of the day, like there's a lot of workloads in the form of the agents would be working inside of any organization. There will be communication happening between all of them. And there's a lot of issues of how to make it secure. Like the least privilege kind of approach, how to implement it in the right way, identity, being able those agents, and the code of it couldn't be exploited. So like there's a lot of to unpack there on its own. And we'll talk about this a little bit later on. But what I was thinking about yesterday is that did you see, Tim, like all this releases from the OpenAI and Anthropic, where they basically show how the AI is managing the computer in a way and like do whatever you ask. You don't even need to work with the APIs or the apps. You just like basically spin up a virtual machine, give it to the some form of the agent, and like it just
Yeah.
work with the computer as the human would be. And this we're moving to that really, really fast when maybe like instead of hiring someone junior, you can just like spin up a virtual machine and give a few tasks just to this agent. But like this new concept of AI managing the computer, like it's like it's increased the attack surface, like in all forms of security we need to think about, which is a fascinating problem to solve in future.
Yeah, absolutely. That agentic AI agents, the ability to actually take action somewhere else or manipulate data, that really does expand the attack surface. You're absolutely right. Yeah.
Yeah,
So
my
we can
point is
talk.
like, yeah, we're also in the Wild West. It's really like nobody, like we're all as a community collectively try to figure out like what is the right approach to it. So like we're doing this right now by sharing what we see, but we're happy to learn like what everybody else is doing too.
Except, one of my favorite topics to or things to say maybe is that we evolve technology, but the threats often stay the same. So even when we're talking about something new like AI agents, when we talk about securing them, a lot of the threats, while targeting a new tech or a new platform, are similar or the same to threats that we've dealt with in the past. So we put together a little list here based on what we've seen of the types of threats that are relevant to agentic AI, if you will. And for the most part, these look like things that you've seen somewhere else, right? Jailbreaks are not a new thing. Jailbreaking an AI agent might be a new thing,
It is
but
amazing.
jailbreaks in general are not new, right? And we talked about injections, right? As a threat. It's a different target, right? It's now a prompt versus an API call or a SQL server or what have you.
Yeah, the question I'm usually asking right now, the product security leaders, is like, do you think the AI security would be part of the product security? And like the answer is usually yes. I mean, like it's just like the new scope of the threats you need to think about, and kind of you can't just think in the way, oh, I will deal only with the SQL injections, like and everything that was before. I mean, like this is your new reality that you need to think about the new threat vectors and yes, like mostly related to the product security right now. So like at least in the concept of it, in the context of this conversation. But you're right, like jailbreaks and prompt injections, those are the new things. At least those are the new flavors. But if we see about like the breaches of the AI-based applications, I mean, like we don't need it to go far. I mean, like, did you guys read yesterday the report from Wiz and like the DeepSeek vulnerability? There is, the number one app in the US App Store, and everybody's talking how this small application with a small team basically crushed the stock market of the top companies in the world. But in reality, what the vulnerability they just had the ClickHouse database exposed without any authentication. I mean, this is the most used AI app maybe today, and like it suffers and gives the whole access to their internals and their users just by exposing the database. Like it was a case 20 years ago, 10 years ago, and today
Yeah,
in the
yeah,
world of AI and agents, like we're still talking about the same
it's
issues,
the same
just
stuff.
the
Yeah,
synchronous configuration.
same risks. Yeah, it's true. It's true. So we talked a lot about AI there. Let's actually talk about the API aspect of it now, because the other conclusion, the other key finding from the report is that APIs really are at this point the attack surface. Like if you're worried about an attack surface, it has to be APIs. So why do we say that? I think we can start with this chart looks very similar to the previous one, but slightly different numbers. This is our analysis of the of CISA's known exploited vulnerabilities catalog. So CISA puts together a catalog, they maintain it, of vulnerabilities that are known to be exploited. So these are conditions not just that are theoretical, but that are being exploited in the wild today. And we looked at how many of the vulnerabilities in that catalog are related to APIs specifically. Last year, 2023 data, it was 20%. And in this year's analysis, it moved up to 50%. So literally 50% of the known exploited vulnerabilities that CISA tracks are specifically API vulnerabilities. And I think that and that increase tells you what direction we're headed. It's clear that you need to be worried about APIs as part of your attack surface. These are the things that attackers are exploiting actively. It should be a top concern in terms of securing your environment, your infrastructure.
Yeah, can you unpack what is KEV for the audience that may be not familiar with this abbreviation?
Yeah, so that's the known exploited vulnerabilities that the catalog that CISA maintains of vulnerabilities that are known to be exploited in the wild. So it's not just theoretical vulnerabilities, but things that are actually being exploited.
Yeah.
Yeah.
Think about those vulnerabilities that you need to care about today.
Yeah. So a key question here would be why are API vulnerabilities expanding? What's driving this expansion in the attack surface? I think there are a few different reasons, Stepan. We talk about these a fair amount, but do you have a favorite? On the slide here.
I mean, this is one of the topics when we always can find the justification, but it's a kind of everybody can feel it. Like the APIs are everywhere, and there's like we like this phrase. There is no AI without API, but there is in reality there is no life without API right now. It's all about the API. So no surprise, we just have all those charts, whatever chart we show, like it's growing exponentially. But yeah, that's just like a reality of what we're dealing with today. And obviously the API usage is growing. There's a lot of complexity in the new software. And it's not necessarily clear for everyone how to deal with this new world. I mean, if you're adopting, let's say, GraphQL or maybe gRPC APIs, or maybe you've been working with the SOAP for years and now you're moving to the REST. I mean, there's a lot of things that you need to keep in mind that it's not necessarily easy or straightforward. Like the complexity of those software like is increasing, and we just all need to get the new skill set to work with all these new flavors of the APIs. But you can double down on what do we have on the slide here.
I think so often we talk about technology as evolving, and I think it's more accurate to say technology doesn't evolve, it aggregates. So there's a combination here of expanding API usage for new things like AI as an example. But at the same time, there are legacy applications, legacy systems on top of which new APIs are being put to provide access or provide integration, or where legacy APIs already existed. So I think this combination of new and old is relevant as well. So it's important to
you
keep in
spot on.
mind.
You
Yeah.
spot on. I mean, like we can be, and forgive us the audience, like we can talk a lot about this new exciting things related to the AI, but in reality, what is often overlooked is those legacy applications and APIs. Yeah, and
Well,
I think you're spot on, Tim.
and if you think about what we were just talking about agentic AI, right? So you have AI agents now that you want to be able to take action to do things in your environment. They need to connect to often systems that already existed that you want to automate. That means that system either it has an API, could be a legacy API that already existed, or you need to put an API on top of it. So we're going to see the development of agentic AI drive the adoption of AIs for existing legacy systems as well in order to integrate them into that sort of new set of capabilities.
Yeah, I guess like what is the practical insight from this is that maybe, and this is what we preach a lot, is that whatever tools and processes you have in place, it's better than you have the same tooling, to deal with the legacy APIs as well with the modern APIs. I mean, you can use like different kind of tools for one thing or another. It's better to have the same processes, same tools, same people who are trained to use the same thing. Mm-hmm. I love this graphics.
So I said we would come back to this topic at the beginning. Late last year, we put together I would say we put together a project, and then we were so surprised by the results that we put together a report for it, and then integrated the results into this report as well. So there's a separate honeypot report, but we pulled some of those results into the annual ThreatStats report. What we did here is we stood up an API honeypot, so specifically designed to look at the time to discovery, the types of interactions that were occurring with newly deployed APIs. And we were just astounded that there was an average of 29 seconds before a newly deployed API was discovered and first interacted with. And I think the maximum time frame, if I remember, was 34 seconds. So under a minute. If you're deploying new APIs, someone is finding them in under a minute. The other piece of data here that's particularly relevant is this comparison we did of the speed at which data can be extracted. So we used sort of as a benchmark 10 million user records and looked at three scenarios. Traditional web scraping, which, as you can imagine, is fairly slow. And so that's the one at the bottom. Using a single request, API methodology, so just request after request after request, which took for that 10 million records about a minute. So that's where you go back to that Dell incident. There were 5,000 requests per minute, over a period of 3 weeks. Those were single requests. But some of the newer technologies like GraphQL and even some of the older technologies like XML RPC allow for batching of queries. And when you start looking at batched queries, that amount of time it takes to extract data drops significantly. So, I mean, Stepan, when you're talking about, under 10 seconds to pull out 10 million records, what does that mean for, securing those APIs? What's the implication for the, the security practitioners?
I mean, the most practical thing to think about this is that you don't have time to react. You need to have security controls that would be effective almost immediately, because any delay here, we're talking about the seconds. I mean, even if you have something in place that can detect attacks and send an alert to the team on maybe some other product, I mean, the delay of only 30 seconds would allow attackers to execute and get an access to a lot of API records. And you can't afford it. So like, while building the security controls, you just need to think that they need to work in real time. And like, I mean real time. There's no way you can delay the mitigation with these kind of things. And I think since we're talking about the AI a lot this webinar, this is even more important, because if you see right now, what are the crawlers out there? Like, who is crawling the internet, who is consuming the APIs? You can see a lot of new actors, which are legitimate AI companies that are basically scrolling and parsing. There's a lot more that are not legitimate. And I don't know, every company is different. Everybody has a different term of service. Even getting back to the example of the DeepSeek, and now like there's a lot of speculation in the media and the official quotes from OpenAI and Microsoft about like abuse of their APIs to train the model. So like everybody should be thinking about this, because APIs are by default are very easy to abuse. They have been developed for the bots. They are developed for the other software to be consumed, or we can say they're developed to be consumed by the agents nowadays. And it's a very hard problem to have right now, just how to protect yourself against this abuse. And especially because you have only seconds to react. Otherwise, there will be consequence of delay.
Yeah, I think you're exactly right. You hit the nail on the head. The problem is, by the time you can react, your data is gone if you're not reacting in real time. Yeah. So of course we want to talk about next steps for folks. What is it that you can do in the sort of face of this data and these conclusions? And we have this information in the report as well with more detail, but we break it down based on sort of the CISO persona and the CIO persona. And there's an interesting what is it, sort of other topic here about who owns API security, because APIs are such an enablement function that as part of the business they tend to be owned by the CIO. At the same time, the CISO is obviously responsible for security, often application security. So there is a sort of shared responsibility here. Both the CISO and the CIO have a vested interest in securing those APIs. So, Stepan, what's at the top of your list in terms of advice, practical next steps that the CISO or the CIO should take given the data in this report?
And so I'm just looking at these illustrations and I'm thinking that it's an interesting take of how the CISO and CIO can look like. Maybe this is already reality. But yeah, I mean, if I put myself in the shoes of the security leader, I think everybody should get together in the room and just basically say, hey, we need to think about the first principles here. There is a lot of new stuff happening. There is a lot of, problems that we're dealing every day. but we need to have some kind of framework, like something we will agree on. And that will be like, you don't need to have a sophisticated document or uh, uh, brainstorm, really. You need to start with something that will just guide the actions throughout the organization. You need to think about like what is new in the world when a lot of employees are using your APIs with AI. Your engineers are introducing a lot of endpoints and they're now talking with external entities or maybe internal APIs, they feed the data into the LLM. What is changing when your existing workloads are operating with the data that is coming from the LLMs? And as you know, there's a lot of unpredicted results that LLM can produce. So you really need to just kind of like map out like what changed over the course of the last few quarters, maybe a few months, really, and establish some kind of framework. It should be simple to start with, but this really helped in kind of maybe alleviate some nervousness, kind of like, and just help team to think about the AI in a more practical way. I mean, like, it's very easy to think that it's even more hard. We will lose our jobs, this kind of stuff. But I just find by talking with a lot of people in the field right now that whoever is very confident that they understand like what is AI, what changed, they feel much better right now. They just say, hey, these are the three things we're starting doing. These are the things we're thinking about, like how AI is impacting everything in our organization. And I think this is really applicable both to the CISO and CIO right now. Just understanding like what are the changes really happening. And then you can scale down like all the practical things. You can start doing like API security audits. You can subscribe to all the TI related to the new AI vulnerabilities. You can set up the incident response plan. But all those things are really possible if you understand the core issue and like what are the new implications for the business continuity and security. So like I guess that's the most important thing.
Yeah, I think that partnership between the CISO and CIO is really important. Having the CISO responsible for that API security framework, the CIO responsible for integrating that into the business strategy overall, ensuring that there's cross-functional collaboration, outside of just the security team. That really does make a difference in terms of driving
And
change.
even more, I guess it's even a board level thing. Like when the board level should get together. There's a CISO and CIO, and there should be an honest discussion, which is hard to have it really in an honest way. But the topic is the following. I mean, we wouldn't be able to innovate and catch up, and we wouldn't be the leader if we don't start to apply AI across the board.
Mm-hmm.
That's the fact. I think everybody will be aligned with that. So what's the question is though, like what pace you can afford and what are the compromises you can do on the security side? Because like if you're using much more AI, if you're introducing much more AI workloads, if you're introducing more and more agents and giving flexibility to the employees to use more and more AI products, you inevitably compromise some of the security protocols that you have in place in your organization. So like this balance is really hard to find, but there should be an honest discussion between CISO, CIO, and maybe the board on external, like what are the new risks and like what is our risk tolerance here? If we move move faster, we just need to be prepared that like we are compromising some of our established security procedures in the way how we do business. And there should be an open discussion. I'm not saying that like everybody should be happy about that. It's more about the plan. Hey, we're maybe less secure, less protected here. We will work on that in the timeline of the next 3, 6, 12 months. But everybody should understand this is a risk that came from this new reality.
Yeah, absolutely. So I'm going to remind everybody at this point that if you have questions that you would like us to answer, feel free to put them into the LinkedIn comments or into the Q&A in Zoom. I've got 2 slides about Wallarm itself, and then we'll go through the questions and see if there are some for us to answer. So we want to talk a little bit about how Wallarm can help. Obviously, I started by saying that part of the reason we do the API Threat Stats Report is to help us improve our product. So it's worth sharing a little bit about what that product does. Um, our goal is to really address a couple of specific API security challenges. The first of which is a lack of visibility and into the API inventory and to the risks that are presented there. So as Stepan said earlier, most organizations don't know how many APIs you have. You can't protect what you don't know about. So understanding what's in that inventory, what risks they present, is a key challenge for many organizations who have APIs. And we talked about the speed at which data can be extracted. The challenge there is really that lack of runtime protection. Really, real-time blocking of attacks is a challenge for most organizations, and it's certainly an important one. And of course, I've never met a security team that tells me they have all of the resources they need. So addressing lack of resources both through the product itself and what it automates, but also through the offering of co-managed or managed services to operate the tool. So if those are the challenges, what does the product actually do? What does Wallarm do? So fundamentally, Wallarm is designed to detect and block API attacks. We provide the ability to examine the traffic for your APIs and extract a complete inventory of the APIs along with a whole bunch of useful information about them, including what risks they present. So that's the API security posture management piece and API discovery. We then monitor that traffic looking for attacks and abuse, and we block those attacks and abuse as well. So you can think of it as protection for the OWASP API security top 10 and beyond that as well. In addition to that, Wallarm offers an external API attack surface discovery capability that also looks for API leaks. I'm actually going to answer one of the questions here because it happens to be topical. Someone had asked, why not automate and choose a tool that searches repos for secrets? So, sort of secret scanning, and then build that into your CI/CD. Totally reasonable thing to do. You should search your source code for leaked secrets. There are tools to do that. What's missing from that is the ability to search other places for leaked secrets. So things like public GitHub repositories or public Postman collections, not associated with your organization, where a key or a token or a password might be leaked. Or for example, if you're leaking API keys in the web properties themselves, that's what our API leak detection looks for. So those are the basic capabilities of Wallarm. Again, our goal ultimately is to detect and block attacks, and that's what we're after. So I'll go ahead and look at some of the questions. There are a couple slides here that you can look at while we aim to answer those questions. The first one I've got here is Wallarm a SAST or a DAST tool or both? So that's a question about security testing. Does Wallarm do source code static analysis or dynamic analysis testing? Wallarm does have some security testing capabilities. I wouldn't categorize us as a SAST or a DAST. We're generally not looking at source code. We do have the ability to take attacks that we see in production and replay them against your non-production APIs in order to find vulnerabilities before you would push them to production in your environment. So there's a testing component, but our core mission in life is to detect and block attacks. That's really what we're aiming to do. Thank you for the question. Let's see. If we have any in the Q&A. It does look like there are some in there.
There are a
So
few.
one here is not so much a question as a comment about, we were talking about how OWASP has categorized injections. I won't read this whole comment because it's quite long, but it points out that that OWASP still includes injections. They've rolled them into a broader category called unsafe consumption of APIs, which is API 10. And I think you can interpret that as taking a higher level view, or you can interpret it as putting injections, which we put at the top of the list, in the last OWASP API category. I think that's an interesting debate to have. Let's see.
How to compare Wallarm API security versus Azure API Manager? I guess
Yeah,
this is the question more about the API security versus API management gateway software.
yeah. Do you want to answer that one, Stepan?
So both like there is no we actually we partner up with Kong and MuleSoft. So we have a lot of partners in the API management. And when we have join webinars together, join meetings. So we usually talk about the two aspects of the API security. You need the foundation to build your API in a secure way. You need authentication, authorization, rate limiting. And this is the part related to the API management. However, if we talk about the discovery, real-time threat prevention, API security testing, this is where you need the API security tooling, like Wallarm.
Yeah, good. So there's one question here about pricing for Wallarm. So Wallarm's priced based on the number of requests per month. So it's a volume-based pricing, and that's the basic idea. Of course, it varies depending on your volume. And here's a good one. So there's a question: any advice for creating an API that is secure, or do we just need to run Wallarm to find out? Stefan, do you have advice for creating secure APIs?
Yeah, here's the thing, like even having Wallarm would make your API secure. I mean, it's a combination of different things. We talked a lot about the OWASP API security today. I mean, that's a great resource that everybody should start with to understand like what are the risks in terms of the APIs and like how to build APIs in a secure way. We talk about API management, actually just mentioned API management software, which is instrumental piece to start your API security program by having the proper authentication, authorization, API governance, rate limiting. But then you also need to have, depending on where you are in your API security maturity cycle, but at some point you just need to have some tooling to discover APIs that you have, understand like what team is responsible for them. You need to understand like where the sensitive data in and out. You need to have visibility of what's going on with the APIs and being able to do forensic and the incident response. There is a lot to unpack there, but in reality, is like you need to build APIs in a secure way, but B, you also need to be equipped with the right tooling to be able to protect against the threats of 2025.
Yeah, good. Another question here: would we run Wallarm in test stage or prod environments?
It really depends on the capabilities we're talking, because we basically talk about the discovery, detection, protection, and response. So there are some pieces where you're running purely in the production, some pieces that are possible, like for example, testing you can do in the staging environment too. But in reality, when we talk about the APIs, you just need to make sure that your APIs that are in production are actually secured. So I would assume like most of the work and the hard work that need to be done about the production APIs.
Yeah, good. And I think maybe this is the last question. We'll see here. Does Wallarm layer add latency?
That's a good one.
Yeah, it's a good one. Performance is always a concern. Anytime you're adding a hop to, that path, you're going to add some latency of some kind. If you have zero tolerance for latency, you can run, something that's out of band where there's no interaction with the traffic whatsoever. You of course then give up the ability to actually block those attacks. So, we work with our customers to engineer, an architecture that is acceptable in terms of performance. Our security edge offering, which is our fully hosted deployment method, is designed to deploy the Wallarm filtering capabilities as close to your APIs as possible. We would say at the API edge, which is specifically designed to provide optimum performance, with the minimum amount of management. Otherwise, when you deploy those nodes, you get to integrate them into your environment in ways that work for you. There are lots of different options that meet frankly meet the performance needs of some very demanding customers. So lots of choices there.
Let me give you the short answer though. Like Wallarm will not add noticeable latency, which we proved like many times by working with some of the largest organizations. And this is like a big kudos to all of the engineering team we have here. One thing is to detect attacks in real time, which is a problem on its own. But another thing is how to make sure that it's scalable and it's not adding the performance overhead that would be accepted by the engineering team. So like that's a huge accomplishment from our side, which we're very proud about.
All right, great. I want to thank everyone for attending. We're at the end of our time here. Thank you, Stefan, for the commentary and the analysis. Hopefully it was interesting for everyone. It was interesting for me. And thanks to everyone who attended. And we look forward to seeing you at the next Wallarm event or webinar.
Totally. Thank you, team. And Brandon asked to keep the broadcast for another 30 seconds. But thank you all. Thank you all for joining today. We're always here to talk about the API and like new reality of the AI too. So like, don't be shy, reach out to us. We're happy to have a conversation, maybe answer some of the questions that you asked in the Q&A. And I appreciate like to have so many questions today. We can just unpack and discuss them in more details. Thank you all.